Hey guys, today our lesson is 5.5 and we are going to talk about rational exponents here. So we need to talk about the square root of x and how it actually rewrites to be x to the 1/2 because the 2 is in the little index area and the 1 is where the exponent would be if we were to write a 1. So that means that for our second example over here, this turns into x to the 2/3. And then finally, our last example before we get into actual equations, if I were to rewrite 8 to the 1/3 power into a square root form, anything that's on the bottom of your fractional exponent goes in the little index area, or the nook as I call it, of the radical. And then 8 is our base, and it's really to the first power. We could go ahead and continue to solve that down or simplify it down and get an answer of 2. So let's use what we just learned or what we know to solve equations. So the nice thing here is that if you think about if I were solving the problem, I'm going to do it down here at the bottom, x squared equals 16. We know that we're really going to take the square root of both sides to solve that problem. And now we know that we can rewrite the square root of 16 as 16 to the 1/2 power. So if you see a 1/2 exponent and we relate that to the original 2, hopefully you realize that those are reciprocals of each other. So basically what you need to understand is we're going to be taking our equations to a reciprocal power. So I'm going to delete this part over here if I can get it to delete properly. Let's see here. Of course not. So let's go back. So we're going to just call that a loss because whatever, it doesn't really matter. So let's go back to this guy. So up at the top on example A, we are going to take each side of the equation, not to the 1/2 power like it's showing, but to the second power. Okay? So if we use properties of exponents, when you take power to power, we should be multiplying. And 1/2 times 2, if you look at this guy right here, 1/2 times 2, that works out to be a 1. So the good news is that this turns into be 3x minus 1 equals 2x plus 5. And from here, we can go ahead and just solve our problem. So we're going to move our x's over to the other side. Oops, sorry. And that becomes x minus 1 equals 5. So then if we just finish this off by adding 1, we know that x is going to equal 6. We tweaked the numbers on our worksheet a little bit because when we printed it, this didn't, example B didn't work out to be a nice problem. So if you're looking at worksheets you picked up in class, most likely this is just a 2, and then this over here is really a minus sign. But again, that gave us bad numbers, so I decided I'd be nice and give us nice numbers on our recording. So we're going to get our thing that has an exponent right here, our base and exponent all by itself. So we're going to isolate that guy. We didn't have to isolate before because everything on this problem had an exponent. So we're going to isolate the guy that has the exponent by moving the 12 and moving the 3 first, and then we'll deal with the exponents. So we're going to go ahead and add 12 to both sides. You end up with 3 times 5x plus 1 to the 1/2 equals 12. And then we're going to divide by 3. So you end up with 5x plus 1 to the 1/2 equals 4. Once you've got that set, then we need to think about getting rid of this exponent again. So if you look at our exponent up here, it's the same type of exponent that we had on the previous problem. So if I want to undo that, I'm going to take both sides of the equation to the reciprocal power, and the reciprocal of 1/2 is a 2. So we're going to take that to the second power and take that to the second power. So the nice thing is that these will cancel. And then when we go back to work this problem, we're left with 5x plus 1 equals, and then 4 squared is 16. And then this is just back to Algebra 1 where you solve your problem like normal. So we're going to subtract 1. And then you get 15 equals 5x, so that means x is going to equal 3. Okay, I'm going to try and erase one more time and see if I can get some of this to go away so I can work the third problem. If it doesn't work, we'll just go to the next one. That's what I thought it would do, so let's just go ahead and jump to slide. So we need to, let me make sure this is my background real quick. Okay, so we're going to give this a shot. So let's look at number 1. For number 1, we have 3x plus 1 to the third equals negative 5. Luckily, there's nothing on the outsides of our base and exponent combination, so we don't have anything we have to move around. We just need to undo the exponent. So I'm going to start that with taking it to the reciprocal power. So I'm going to take this to the third power as well as this side. Okay, so the nice thing on reciprocal powers is your exponents will just cancel, leaving you with 3x plus 1 on the left, and then negative 5 cubed means negative 5 times negative 5 times negative 5, so that means we're going to have negative 125. Then all we have to do is solve like normal, so we're going to subtract the 1 away. You end up with negative 126 equals 3x. And then when you divide by 3, you end up getting x equals negative 42. Okay. You always want to plug these back in to make sure they work. So grab a calculator and plug in negative 42 for the x up here at the top. And then you can enter 1/3 as an exponent in your calculator. Just make sure that you get negative 5. So now we're going to talk about example 2, if I can get there. All right, so for example 2, we have more going on in this problem because this is the business that has the exponent, but the 6 over here and the 3 over here don't have exponents, so we need to move them away so our base and exponent combination is isolated. So we're going to add 6 to both sides and be left with 3 times 2x plus 6 to the 4th equals 6. And then we're going to divide by 3. And then we have 2x plus 6 to the 1/4 equals 3. Oh my gosh, equals 2. Let's try that again. Okay. So then we're going to take this whole business to the reciprocal power. So we're going to take it to the 4th. And when you work that problem, you're going to be left with 2x plus 6 equals, and 2 to the 4th is 16. So then we're just going to subtract 6 from each side, get 2x equals 10, and then we divide by 2. You should get x equals 5. All right, so we've got 2 of the 6 done that are going to be important. And then now let's work number 3, if I can get it expanded. All right, so there's a lot of people that make mistakes on this one, not because it's difficult, but because a lot of people tend to attach the 4 to the x to the 3/2. So really, if you think about this, the 4 has an exponent of a 1 right here, so it has its own job. So the only thing that we need to be left with is x to the 3/2. So we need to isolate this by moving the -8 and moving the 4 first. So we're going to do that by adding 8. And then we're going to divide by 4. And that's the part where people tend to have a mistake. So we have x to the 3/2 equals 2. So then all we're going to do is we're going to undo this exponent, but this one gets a little bit more confusing because we don't just have a 1/2 or a 1/4 or a 1/3. We actually have a number on top and a number on bottom that aren't ones, so you have to think a little bit. So we're going to take this guy to the reciprocal power. So if I have 3 over 2 to start with, that's 2 over 3 for the reciprocal. So So then these will cancel. And then this one gives you a little bit of a mess going on. So we're going to have x equals, and then I'm going to rewrite this whole business so that it looks like a square root or a cubed root. So if I rewrite it, remember that this bottom number goes inside the index area of your radical. So 2 is our radicand, which is just the big number inside, and that's going to go to the second power. Well, if you think about this, you really can't take the cubed root of 2. That's too small, and the only factors of 2 are 1 and 2. So we could go ahead and say 2 squared. So if we've got 2 squared, we know that that turns into a 4. And then on the outside, we have a cubed root. So you still have to continue to think about it. Can I take the cubed root of 4? Well, 4, again, doesn't have that many factors. It has 1 and 4 or 2 and 2, but I can't find a group of 3 like factors. So that means that this is our final answer, which is kind of nice. All right, let's work number 4. This one's a little bit of a mess. The nice thing is that pre-AP, you're going to have to work 2 problems, and academic, you'll work 1. So I'll tell you when you can stop if you're academic. So if you're academic, we'll ask you for the positive answers, and then if you're pre-AP, we'll want all answers. So what that means is we're going to just solve like normal, and you'll see a point when we have to kind of start thinking. So luckily, I don't have anything being added or subtracted or multiplying to my base exponent combination. So I'm just going to take this to the reciprocal power. So if my power right now is 2/3, I'm going to take it to the 3/2 power. So this will cancel out nicely, and you're left with x minus 1 equals 6 to the 3/2 looks kind of funny, so I'm going to rewrite this. So the number on the bottom goes in the index, so that means I'm going to have a square root of 6 to the 3rd. And remember, if it's a square root, you don't have to put the 2 in the index. It's understood. So from here, we need to probably simplify this radical, but I can't find the square root of 6. It doesn't exist. Well, I say that. It does exist, but it's a nasty decimal. So what we could do first is cube the 6. So I'm going to do this the long way. If you know that you can shortcut it, go for it. But I'm going to say that I'm going to take the cubed root of 6, which most of us are beginning to memorize as 216. And that means that if we were to break that down to simplify the radical, because I can't do the square root of 216 still, we're going to have 6 times 36, and that breaks down into a 6 and a 6. I could continue on, but I do know that I've already got a pair right here. And since I've got a square root, I'm looking for groups of 2. So this works out to end up being 6 root 6. Now here's where it matters if you're pre-AP or academic. When I take a square root, if you're in pre-AP, our expectation is that you realize that it's plus or minus. If you're academic, we'll understand that you can just take the positive version. We won't make you get the negative version. So all we have left is to get x by itself. So we're going to add 1 to the other side. Notice that 1 cannot be combined with this guy because it has the root 6 attached. So we're just going to do 1 plus or minus 6 root 6. And again, if you're academic, we would accept 1 plus 6 root 6. And that's all we would require. Pre-AP, you must have both answers. Okay, so let's talk about number 4. Oh, I'm sorry, number 5. All right, so we do have one item that needs to move on this one because we have our base that has an exponent right here, but this extra 4 needs to go away. So we're going to go ahead and divide by 4, and we're left with 3x plus 5 to the 2/3 equals 25. So now we can go ahead and fix our exponent issue. So we're going to take both sides to the not 2/3, but 3/2 power. So this will cancel out, and we're left with 3x plus 5 equals, and I'm going to rewrite this guy over here. So we're going to rewrite it as the square root of 25 cubed. So again, there's a distinction here for pre-AP and for academic. For academic, we just want the positive root. So pre-AP, keep in mind that we're going to have to think about this a little bit, but let's do the positive root first. So if I take the square root of 25, that works out to give me 5 cubed. So if I continue that down, 5 cubed is 125. So I'm going to real quickly put a little highlighter mark right here because we're going to come back to that point in just a second pre-AP, but everybody needs to solve this problem. So we're going to subtract 5. We're going to get 3x equals 120. When you divide by 3, x equals 40. So there's our nice happy answer. Now for pre-AP, you need to think about the fact that this guy right here was a plus or minus because we took a square root of 25. So we have one more problem to work if we're pre-AP. So we're going to now work 3x plus 5 equals negative 125. So we're going to subtract 5. You get 3x equals negative 130. Divide by 3. And you can't simplify that, so we'll just leave it negative 130 over 3. So again, if you're pre-AP, you have to have both answers. If you're academic, you just need to have your positive answer over here. Okay? All right, last one on the main page, and then we'll go to the pre-AP challenge side. All right, so from here, we have more going on than just the base and exponent. So we're going to get rid of the 6, and we're going to get rid of the 3. So in order to get rid of the 6, we'll subtract it, which gives me 24 on the right side, and that one cancels. So I still have 3 times x plus 2 to the 3/4. Then we divide by 3, and we're left with x plus 2 to the 3/4 equals 8. So now we can undo our radical by taking it to, undo our exponent by taking it to the 4/3 power. So these will cancel, and we're going to be left with x plus 2 equals, and I'm going to rewrite the right side. So we are going to have the 3rd root of 8 to the 4th. I tend to do my radicals first. I like to get the number smaller if possible before I make it bigger with an exponent. So I'm going to find the 3rd root of 8 to get 2, and now that's still to the 4th power. Notice this time, especially pre-AP, this was a 3rd root, so I do not need a plus or minus on my answer. I only have to do that if it's an even root. So we're going to evaluate what 2 to the 4th is. That works out to be 16. And then we subtract 2 away, and you get x equals 14. So academic, that's all the concepts you need to be aware of. So thank you very much for paying attention. But if you're pre-AP, we've got a few more challenge problems we need to work. And so let's go ahead and continue on for our pre-AP students. So now we're going to talk about fractional exponents that are also negative. The way I like to do this is to continue on with the same method, just to kind of keep everything routine. So what I like to do is go ahead and take, whenever I have a fractional exponent, even if it's negative, I like to take it to the reciprocal power. Well, the reciprocal of negative 1/2 is negative 2. So that means that we're going to end up with x equals 10 to the negative 2 power. And we learned that when we have a negative exponent, we're going to flip it to the opposite side of your fraction. So right now this is 10 to the negative 2 over 1. And that's going to turn into 1 over 10 squared. So then all you have to do is evaluate 10 squared to get 100. There's still a 1 on top, and you're done. Okay? A lot of people get overwhelmed with this one because not only do we have a fraction in the exponent, we also have a fraction in the full problem. But it's okay. It works out nicely, actually. So we're going to go ahead and do the same process. Take each side to the reciprocal power. So the reciprocal of negative 1/3 is negative 3. So then when this cancels, we're left with x equals, and I'll just rewrite this, 1 over negative 4 to the negative 3. So I like to go ahead and distribute my negative into my numbers inside the parentheses. So this turns into 1 to the negative 3 over negative 4 to the negative 3. And anytime you have these negative exponents, they just want to change sides of the fraction. So we're just going to turn it upside down, and the 1 to the negative 3 will become 1 to the 3rd on the bottom, and the negative 4 to the negative 3 will end up as negative 4 to the 3rd on top. A lot of people try and change that negative out front. The only negative sign that changes when you switch sides is what's in the exponent. So then all we're going to do here is simplify this out. So negative 4 to the 3rd, and even if I had entered it probably properly with the parentheses around it, no matter what, parentheses or not, because it's a not exponent, that gives me negative 64 over 1 to the 3rd is just a 1, so my answer is negative 64. So let's come back over here to the next one. Same process, just a couple extra steps. Now we just need to isolate our radical or our exponent. So that's the part that needs to be left alone. So I'm going to subtract 25 to the right side. So that gives me 25x to the negative half equals 75. I need to get rid of the 25 out front. So I'm going to divide by 25 there. And that gives me x to the negative half equals 3. And then I'm going to take everything to the reciprocal exponent. So that's going to be to the negative 2. So I'm left with just x equals 3 to the negative 2 can be fixed by putting it on the denominator. Yeah, there we go. And then that becomes 1 over 9. And we've got one more very similar to that. I guess we have a couple extra problems after that, though. Okay, so same process here. We're going to get rid of the 6 and get rid of the 3. So we're going to subtract 6 first and be left with 3x to the negative 3 halves equals 24. And then I'm going to divide by 3 to get x to the negative 3 halves equals 8. And then I will take this to the reciprocal exponent of negative 2/3. So these will cancel. We're going to be left with x equals 1 over 8 to the 2/3 because I fixed that negative exponent. And then all we have to do here is rewrite and evaluate. So we're going to have 1 over the cubed root of 8 squared. This turns into 1 over, again, I like to do the root first. So the cubed root of 8 is 2 squared. So our final answer is 1 over 4. Okay, This one's a challenge problem. You won't see it all that often, but it's a good refresher or a preview for what you need to expect in pre-cal. So the way I like to think of these is I still have a ratio in my exponents up here of 2 to 1. So anytime I have something that looks like an x squared problem, I'm going to think quadratics. So I'm going to go ahead and get this set equal to 0. So I'm going to pull this -5 over to the other side. And write our new problem. All right, so the next thing I like to do is pretend that these 5s are hidden for a minute. Okay, so we're just going to pretend that they're missing just for the moment. So then if we've got that going on, we've got x squared plus 6x plus 5, and that's something that's easily factorable. Let me change my color here. All right, so we're going to factor this into 2 parentheses. We know that our factors of 5 are going to be 1 and 5, and since all of our signs are pluses, we're going to have plus 5 and plus 1. The main thing we need to realize here is that if we multiply x times x, we get x squared. But we don't need x squared, we need x to the 2/5. So what we could do is consider our current exponent being a 1. However, if we want it to be in terms of fifths, you can simply adjust your exponents to be a 1/5 in factored form. You can always do a check on this because when you multiply x to the 1/5 times x to the 1/5, you add your exponents, and that's how you get 2/5 to match that. So now that you've got it factored, you just need to set up your problem x to the 5th plus 5 equals 0 to find out what our actual 0 is, and x to the 1/5 plus 1 equals 0. So we'll solve those problems. X to the 5th equals -5, and then we'll take each side to the reciprocal power. So that leaves us with x to the -5 to the 5th is -31/25. Same process on the right side, so we're going to have x to the 5th equals -1 because we're going to scoot this 1 to the other side. We're going to take both sides to the 5th power. And then we're going to plug in, or we're going to cross these out, and -1 to the 5th power works out to be -1. Make sure, especially when you have a quadratic, that you go back and you plug these numbers in and see if they work, because every once in a while you'll get extraneous solutions. Okay, so we have 2 left. We're going to go ahead and jump over here. Oh, just kidding, we have 1 left. All right, perfect. So this is our only example with 1 number that is not inside of a parentheses, but I cannot exactly move it to the other side because there's really nothing I can pair it up with. So what we're going to do here is just continue on like it wasn't there and consider the fact that we have exponents of 1/2 on each side. So we're going to take both sides, to the 2nd power. Now here's where people get a little confused because we're going to go ahead and deal with this exponent canceling out to become 1, but there's really an exponent on this 2 over here, so we're going to have to distribute that exponent of a 2 over there as well. So we're going to have the big 2 to the 2nd power because its current exponent of a 1 times the outside exponent of a 2 works out to be 2. So then everything else is nice because this will cancel and you're left with x minus 4 equals, and then again these will cancel over here, so you're left with 2x minus 2. So we'll just keep working here like regular algebra 1 problems. This turns into a 4 And then you have x minus 4 equals 2x minus 2. You get 4x minus 16 equals 2x minus 2. As you continue to solve that problem, you end up with 2x equals, and when you add the 16 to the other side, you get 14, so x equals 7.